In this example, I'm going to take the definite integral of this function as x goes from 0 to 2. Well, no x, this is u actually. Now, it doesn't really matter what the variable of integration is as long as it's all the same. So I've got u. That's totally fine. It doesn't really matter. That's sometimes called a dummy variable. One thing, I don't know how to take the antiderivative of a product. This is something times something, and we didn't have a rule for that. We just had if we had powers or sums or differences or constants. So I need to do FOIL on this first before I can do anything else. So I'm not taking the integral yet, I'm just rewriting. U times u is u squared. Outer and inner, so I get plus 3u and minus 2u. So plus 3 minus 2, that just gives me plus u. Negative 2 times positive 3 gives me negative 6, and we've got du. So now this is my function f of x. We need the antiderivative capital F of x. So this is a power. To do the derivative, I would make the power go down 1. So instead I make the power go up 1. But then I have to divide by the new power so that if I were to take the derivative, when I would bring this 3 down in front, those would cancel. And then 3 minus 1 would be 2. Same thing here then. I increase the exponent by 1. I go from 1 to 2, but I divide by the new exponent. And the antiderivative of a constant, I just throw on the u, and then that's evaluated as u goes from 0 to 2. So I plug in 2. 2 cubed over 3 plus 2 squared over 2 minus 6 times 2. And then I plug in 0. 0 cubed over 3 plus 0 squared over 2 minus 6 times 0. So when I do this here, we get 8 thirds plus 4 over 2 minus 12 minus 0 plus 0 minus 0. So 8 thirds plus 2 minus 12, and then that's just a whole 0. Now, we're going to see a lot when we have a limit of 0 and we plug it into a function. If it's a polynomial function like this without a constant, it always ends up being 0. And the only thing sometimes I've seen students do is they automatically, when they plug 0 into this function, they just write 0 down without thinking about it. There's a time when that's a problem. If I had a cosine of u here, then cosine of 0 is not 0. Cosine of 0 would be 1, and so that would mess this up if there were a cosine in here. So just be careful. You've got to think about it. So this is going to be 8 thirds minus 10. So that's 8 thirds minus 10 over 1. If I were going to change that into a common denominator, I'd multiply top and bottom by 3. So I get 8 thirds minus 30 thirds, so that would be negative 22 thirds. Now remember, we said a lot of times this is finding the area under a curve, but we're not checking here at all on this function to see obviously it's not always above the x-axis. If it was always above the x-axis, if this were always positive over this interval from 0 to 2, then the integral would be positive. Since it's negative, then if we're at least part of this interval, this is below the x-axis. And in fact, when I plug 0 in, 0 squared plus 0 minus 6 is negative. So at 0, this starts out below the x-axis. When I get to 2, 2 squared is 4, 4 plus 2 is 6, 6 minus 6 is 0. I think it's actually just getting to 0. I think this is below the x-axis on this whole interval. So this integral negative, that's representing a negative area. That's actually the area beneath the x-axis.